So let's give it a run. Okay, so it's successfully assembled. That is a big win. So these assemblers, not too different. They support the same opcodes. They're not like, oh yeah, we use slightly aliased opcode, which, I wouldn't expect them to change something that fundamental. It did have to do 2 passes to get through, which makes sense because these symbols here are not defined when it came through the first time. We could take these symbols, jump over them at the top, and then have them at the beginning. Okay, so now I'm kind of curious. What if we diff the old one and the new one, right? So we come over here, and so that's the old one. If we come here and we list, we should have, dice.bin now. And if we access that, oops. Okay, so you can see this is smaller because this one has this write function at the end. But you can see it starts exactly the same. B400CD8916 A0. This guy's A400. This guy was A401. Now the A86 assembler had in it a thing where it would put what it called a signature into its assemble things because it was shareware and they wanted to detect people using it for commercial purposes without paying for a license. So it would make slight tweaks to your program that would not affect how it ran, but would be detectable by the people who knew what was going on. This one again, so B101, another 00 that's now a 1. I wonder, maybe we also moved something? Maybe that's an address? It's hard to say, but you can see that when you compare these guys side by side, they are almost exactly the same, which would make me think, well, we should be able to just take this thing then. If we stuck that write routine on, and these guys are still calling right in 21s in here, just like they did before. This guy still has those DOS program calls. So because we commented out the way to print a number, it's never going to print the numbers, which are the important part of the program, but it would print the menu and stuff. If I got this onto that DOS disk, it would run and we'd see the menu print out. But that's still not what we want though. And maybe I'll try to keep this as similar as possible, right? So we did replace those calls. Actually, they should end up about the same, right? Because we're probably at about the same address right here. F0, 1, 2, 3, 4, 5. Oh no, these are 2 bytes each. So that's A? Yeah. So A. So that's FA is that byte there. And if we come up here and FA is this one here. This one's 24C3. C3 is probably that return instruction, which here you can see a return instruction on the end of whatever function is there. Is there another return instruction in here? I'm curious. So that IO file that we were using had 2 functions in it, but we were only using one of them. So if you look back here, I think it has this proc near thing. So because we define these as procedures in A86, it would say, hey, no one's ever calling this procedure. Don't even bother pulling it in. That saves you some memory. That's my distant memory of that. I don't know if that's even supported in Flat Assembler. Well, I bet it is. I bet they have some way to do it, but we're not going to put in any functions that aren't in use. We're only going to add the ones that we need because we're not building an entire framework. We're just writing the minimum amount of code we need to run this program. So I could probably change these calls. I want to try to keep this part as the same as possible, at least for the initial run, so we can sort of keep track in here that things are staying the same. But as I was saying, so this guy's call is to literally probably the same exact byte right after the $, which is that 24. So here you go to that $, which is the 24. Then you have a bunch of code that's then ends with the C3, which is the return. And here we have a bunch of code that ends with a C3 as well, but that's all we have is the C3. So that means probably our jumps, being that the branches that this thing probably generated were indirect branches, not indirect, relative branches. So they probably are saying move forward this many bytes. So they're going to actually probably have ended up the same size. If the instructions are in the same spot, it's going to do the same thing. I mean, when you look at this code, these guys are very, very similar. I could have does XXD, do you have a diff mode? I'm going to give it an out file though, so what we'll do is we'll do an out file. So let's do diff bin, and we'll just call it dice hex. And so recat that, it should be. Okay, so there's that file, and then let's do the same thing over in the old software directory. We'll just call it old dice dot hex. So now if we diff, actually there's no way to get me diff. Give us some nice color here. Try that minus color. So we're going to start with old and end up with the new one. I was hoping we could get something a little more nuanced. I think I have kdiff3. Check the man page for diff again. Maybe there's a way to do it character-wise. Because diff by default is line-based, but I didn't see anything in there for that. So let's try kdiff3. Kdiff3. The old one, the new one. Okay, so here you can actually see real quickly, it highlights in the slightly different background colors. Yeah, so what you got is you got a bunch of ones are made zeros. That's almost strange. And then you can see right after that $, stuff changes, which is probably where that write function is, ending in its return. Whereas we just have a write function that only returns. I'm wondering if, well, like we could hand assemble this thing to figure out why these guys are 1 over here and 0 over here. It's interesting that they're all 1s over here and 0s over here. Let's look at the code real quick. If we just figure out one of them, maybe that'll tell us what all of them are. It is an instruction that's moving dx into seed, so maybe, right? Is that right? No, it's the instruction after that. Oh, but this might be the address of it, because this is the int instruction. Something was moved from 0 to 1, but I'm betting it's an insignificant change. Like maybe one of these variables is in a slightly different spot. That doesn't really make sense though. It would be this one? Move? Just curious. Like it seems to be a lot of these spots where a word is being accessed. And like so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 word accesses. Is there 14 ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's not a completely unrelated, possibly. Oh, well, we know where the spots are in memory, right? It's these guys here. Oh, you know what? That's it. So 1A4, right? A4. A0, 1, 2, 3, 4. This 16-bit number here is the address for, right, because it starts set to 1 and then starts set to F. So start set to 1 is the seed, and start set to F is all F's is the die. So the fact that this guy is built for a COM file, so this wouldn't have worked. If we ran this on DOS, it would have started to write all over, well, not all over, in like 4 spots in lower memory, and it would have printed the wrong string. So 01A4, so this little ending, right? So 01A4 is the address of the seed. So I don't know if you remember when I said was talking about the COM files before, but the COM files start at address 1000, at address 100 hex. So I said address 100, I meant 100 hex. So because of that, all the addresses in here need to be shifted by 100. So because of that, all these 16-bit addresses get the plus 100. Now we could have done that probably with an org setting or an offset setting in flat assembler. Matter of fact, let's see if there's an instruction for that. Then we can get exactly the same code. I think org was probably the thing I want to look for. Ignores the org directive, and somebody says, well, it looks like it has an org directive. Let's see if the org directive solves our problem. Just for the sake of generating. Now, we don't want to use that in this case because in the end we're running from the bootloader now, not a COM file. But it could be fun to see what happens. So let's just put an org directive at the top here. Org 100 hex. Let's see how that affects our. Okay. So now if we dice bin no change. So if we want to do this, we have to read closer. I feel like org should be what I want. Org should do it. What am I doing wrong? Somebody in the future is probably watching this video and like, come on, Ted. Don't you see it? It's so obvious. Well, that's suspicious. This 250 byte dice.com is here now. It has the value I expect. Is it because I put. Interesting. So it looks like when you put the 100 hex in there for the org mode, it assumes you're building a COM file. And so it built me a COM file. That is wonky. So if I remove. Right, because this COM file, this isn't a copy of the other one, it's only 250 bytes. So we remove dice.com. Yeah, okay. Interesting. So we don't have anything now. Don't have nothing. And now we ls. And now it built dice.bin. That was a real fight. Really dumb, but real fight. Okay, so now I'm going to put a note on this org statement. Setting org to 100 hex causes FASM to generate a COM file. Let's bring that back real quick. And I'm using the H notation everywhere else in this file for the hex, so I'm going to use it here. But we're going to go 16 bits because it's an address. Let's be 16-bit-esque. Okay, so now we can come here. We built our COM file. So now we can generate the hex file from the hex. So we'll do xd dice.com dice.hex. And now we can kdiff3 the old dice, the new dice, and you can see literally it's exactly the same all through here up till we get to the point where we have what's probably our write function. So we could use this to build a COM file, and maybe we can I want to create a Makefile for this at some point, so maybe we can make a Makefile that builds a COM file and a master boot record. So now we're going to, actually let's save it like this, and we can commit it, right? So let's see, git status. We have dice bin, com, hex, sim, and hex. The only one we care about is dice.asm. All those others are generated files. We'll do git. Okay. So before we do that, let's look at the diff here. So you can see that we added that org statement at the top, and we can see all of our changes are actually pretty minimal. Do we have a line ending problem here? Possibly. We're going to commit it though with this change, and that won't fix the line ending. So this is obviously a old, yeah, right now this is Windows DOS line ending. So, because it's going to mark every line as changed, which masks your changes. Obviously this file is an old Windows, well, I mean, it's a DOS program. So, it's using DOS line endings. So let's commit this. Builds cleanly with FASM. Generates identical COM file. Now I could make it generate a fully identical COM file by bringing in that IO ASM, but I don't really want that. So now let's clean up those line endings. We're going to let Kate do that for us. Click Unix here. See, it needs to be saved. Save it. Okay, so now if we do a git diff, see, every line is changed, but in a unremarkable way. So then I can say switched to Unix line endings. So now, we don't want this org mode actually in here. So now what we're going to do is we're going to make this file actually boot, the master boot record. So we need to org it to, I think it was 7C100. Now, once again, we have that sample. So here, 7C100 hex. And then at the end, we need to make sure that these bytes end up at 510. Or, yeah, 511, 512. And there's really no reason not to just bring this over. I think there's got to be a better way, though, than padding it with zeros. I know in the 6502 assembler I was using, I could give it a memory map. So I have no idea what most of this code does. I've only watched the first couple videos. I'm assuming this one tells it to be in 16-bit mode. Real mode, as it were. Let's line this up. There we go. Actually, move this guy down a line. And I can actually put all these org statements after the title. Okay. So now theoretically, we could run this. What would happen when we run it, though, is it would call interrupts that don't do anything and call functions that don't print anything. So nothing would get displayed, so it still wouldn't be very interesting. And my guess is probably these interrupts would just lock up. Or maybe throw an error. Like, when I say lock up, I mean they probably don't have returns on the other side, if they have handlers at all. The box is probably smart enough to have its initial boot state be all the interrupt interrupt vectors point to something that just returns from interrupt. But that's fine. We don't need all that. What we need is a way to see how this goes. So we have a lot of junk here right now. Let's remove some of this stuff. So we're going to remove dice.bin and dice.com and dice.sim and dice.x. We'll keep the old one just in case we want to do a comparison to it again. Okay, and now let's make it again. FASM. Now we got bin. We look at the bin file we got this time. Okay, so now you can see that it got the 55AA right at the 5/12th word there. But this starting part still looks exactly the same as this starting part. Instead of being off by 100 from here, so instead of starting 0, 1, they start 7C. So we are now well into, and 7C happens to be pipe, so we can now see that there's all these pipes here in the ASCII version. Yeah, so I think we're going to commit it with added boot code, and then we can pick up next time with writing the two functions we need, one of which is going to be write num, and one of which is going to be write line. So we'll even allocate room for them. Okay, so let's commit those. Well, let's real quick test. Built it. Looks good. Let's commit it. There. Make legal. Good. Okay. So with the fight we had with this org mode and getting all of this lined up, and the fact that it was really fundamentally an output file name problem, I think what we want to do here is go to making this Makefile. Right, we're gonna step up that. So let me touch a Makefile. I don't know if you're all familiar with Makefiles, but fundamentally we're just gonna, it's gonna give us a sort of a controlled interface for doing all of our build processes. So now all the build processes in this thing are single lines, so it's not going to bias that much, but it's still nice sometimes to have things a little ordered. So I am going to open a Makefile I have in other programs just to help me get my syntax down. Actually, let's grab one from the ternary stuff. I think the ternary emulator has a pretty good file. So it's my quick Makefile. It's a little gigantic. This one generates like documents off of C code and stuff, but we're not writing this in C, so I don't even know if we need most of this stuff. We have a reference now. Anyway, so we're going to start with, so our first targets are default target make. So we'll do the same thing where we have a package, and our package will be dice.bin. So that's what we're going to try to generate. And the reason we use a variable here is so that we can more quickly update it. Now, we're not going to use a linker on this project. So we have one source, right? Source is equals dice.asm. Package is going to depend on our sources. And the way we build it is we do FASM. We'll do it this way. Use our assembler. Let our assembler FASM. We take as an input our sources and output our package. This will probably break if we have more than one source on here, because I don't think that's the way this program works. This program being FASM. But if we upgrade this later, we have some room to expand it. So I would like to have a clean target. So in order to clean, we're going to rm. We're going to keep the bin file because that's our target. Well, we'll make it clean all. We could put in something here to generate the hex file as well. So in order to build our hex file, base.hex, we need to have base.com. Now we can use xxd. Always mix this up. It's like at is what we're going for, less than is the input. So that will build the hex file. And we could do this as, I said dice.com there. And this is why variables are useful. Okay, so that will get us the clean we need, and I'll build our target correctly. Is there anything else we really want to make rules for? So what we'll probably do is eventually put in here like a run target, which we'll call box. And I think that is all we need for now. That's a basic Makefile. Let's clean up a couple other things here. When I do git status, has all this junk. So we'll ignore the hex and bin files. Touch git ignore. So what we're going to do is we're going to pull the box configuration file that we were running this guy in over to here so that we have an initial box config as well. It's just like a 3-line box config. Very similar actually to the one from the Case of Fuego video. I went with the slightly less Unixy .boxrc with, and instead went with boxrc.txt. But that's because I don't want it to be a hidden file. I want it to be readily apparent what's going on here. And actually, while we're here too, let's make a README file too. I'll make it a markdown file. Now we can go into Kate and open all those files. I just type .git ignore. Then open. So we have the Makefile. So it knows this one's a markdown file, and it knows that's a git ignore file, and this one it says is a normal file. So this isn't right because we don't want to use this free DOS image that I was using. Instead, we want to boot to dice.bin, and that's it. I'll just go through this file real quick here. So this is a command file for the box emulator. It says we're going to boot to the A drive, which is your classic first floppy drive in PC BIOS. And then we're saying that first floppy drive is a 1.44 meg disk drive. And we're using that dice.bin as the image for that floppy disk. Now this is obviously smaller than 1.44 megs, but it probably either mirrors this or treats it as a all zero fill. And then status is we want the disk to be inserted, and then by default the Debian version of box uses the display library X. It was very, very slow, but if I just change it to SDL2, then it worked. So you can take this line out if you don't have a problem with box running really slow on your system. I do, so it's in. Git ignore, we do not want to have Git ever add any hex files. So we are going to do star.hex, and we don't want to add any bin files, star.bin. Now if we come back to here, and we do a git status, you'll see we have our box source file, the git ignore file, the make file all listed as untracked, but we no longer have the bin or hex file. Now this hex file we might actually want, and we could actually intentionally add that, but I don't know that it actually adds anything to this thing. I mean, it's probably a reasonable reference. I assume it's going to add it if I explicitly add it. Well, we'll find out, won't we? I could, I suppose, be more specific and say ignore dice.hex and dice.bin, but meh. And then my setup doesn't do this, but a lot of editors will put tilde files at the end, and we don't need those bothering us either. So then, this Makefile, we actually do have something we can clean now. So if we want to, we can now have clean all depend on clean. Now we have to make this -f. Because otherwise, if there isn't a file, it will fail. And clean is going to get rid of the hex files. So if you clean, it gets rid of the hex. Does that make sense? Yeah, sure. Clean all, clean hex. Doesn't matter. We're probably going to usually clean all anyway. So then the README file, we're just going to put a little thing in here so that when I stick it up on GitHub, so this is a solid dice roller boot. So it's a dice roller for your bootloader. This simple assembly language program can be invoked directly by the BIOS bootloader. The actual program is just a simple dice roller with accumulator functionality. Files plus -1, which gives us all the files in the directory. Read the bin file. Also going to get rid of the README. Control-Shift-B puts this editor into block mode, which lets you select a two-dimensional block of text. Many editors have this feature. It's super great. Doing stuff like putting vertical lines in. You sometimes want to do. And when you're in this mode, it lets you arrow through empty space. There we go. And so now we can put in descriptions. Now it's actually easier to go back to out of block mode. And so the box, then so this is setup to test with the box emulator, the actual program source, Makefile to build and run the program. Go back to block mode. There we go. And so that'll create a table in anything that reads Markdown. So there we go. So now I have a quick description, a Makefile. I think we're all good. So let's get all that committed. Now I haven't tested the Makefile yet, but I actually want to commit stuff first so that this way, just in case I mess something up, I can sort of restore it. I mean, unless I destroy my .git file repo, but I think that's unlikely. So we're going to add the .git ignore, the Makefile, the README, box source. You know what, we're going to add the old dice.hex file as well. It's complaining about it, but we're going to add it just the same. Now we can do git status. Now we can git commit. That hex file is going to be deleted by our cleanup, so let's undo that. And let's just move it somewhere where it'll be safe, and then I can delete it myself later. So let's copy it first. Copy old dice.hex up a directory, and then I can git rm old dice.hex. Okay. Now we can git commit and added some build infrastructure to maintain the build. Okay. Now there's nothing in git. And so now we have these files. Let's do make hex. Oh, sorry. Make dice.hex. And so I made the hex files. And now if I do a make clean, we see that I got rid of the hex files. And if I do a make dice.hex again, now I do a make clean all, you got rid of everything. So that's great. And so now if I do a make run, it should build the bin file, then let's look at that here. So if I do make run, it should say we need to actually have the bin file. Oh, let's actually test that with the hex file as well. So if I make dice.hex, you see that it first builds the bin file and then builds the hex file. If we want to, we can make this guy silent so we don't get all this noise. You can do that with the virtual target. I think it's like this. Yep, see. So now if we do make clean all, it just runs. So the files will disappear, but if we do make dice.hex, you see that it ran the assembler. And we ls, you see that we got both the bin file and the hex file. If we cat dice.hex, there it all is. So now if we do make run, this should launch box. Now, this is going to be problematic because we don't have a program that's going to actually run well in box yet. But we'll give it a try anyway. What happened here? I think something flashed on the screen there, but it's gone now. And my computer just kicked into high speed, so it's probably running away. And I think we'll call it there. Okay. Well, good luck, and we'll pick this up later. Subscribe or come back often to catch the next video. Or come follow me on GitHub. Have fun out there, and keep on crafting.